Okay, so the second roll should take just a little bit more than one time, and it's going to be 6/5. Okay, so why don't you roll the second die?
Let's see, we roll. We get 6.
Okay, that's fine. Now, what are the open slots here? What's the probability on our third die?
It's 2/3 that we're gonna get a new one.
Okay, I'm going to write it as 4 out of 6.
Alright. Makes sense. You have 4 open slots out of 6 of them.
Okay. How many rolls do you think it's going to take here?
Maybe 6/4.
Okay, why?
Well, I mean, it has the same pattern. It's gonna be a very similar series and everything that we saw before.
Yep.
So it sort of makes sense that we should have the same pattern going on.
Okay, and let's look at it just from a numerical point of view. Is 6/4 or 6/5 bigger?
6/5 is 6/5 is smaller.
6/5 is smaller, so that means 6/4 is.
Bigger.
It's bigger, and so it's gonna take more rolls.
So we expect it to take more rolls here. In this case, 6/4 is 1.5 rolls. Okay.
Alright.
So why don't you roll and see if it takes.
1.
All right. Now we have three spots open out of 6.
So, well, this should turn out to be 6. It should turn out to be 2 rolls.
2 rolls. Okay, now does this make sense intuitively here? This is a little bit an easier one to intuit.
Well,
How many rolls on average do you think it's going to take?
you have a half chance of getting it.
Uh-huh.
So, on 2 rolls, then that should.
Well, expected, you got a half and a half, so with 2 rolls you should expect to have, you could have 1 you're repeated and 1 not repeated.
Okay.
Just because you have the halves.
All right. Is there situations where this might take more than 2?
Well,
Oh yeah,
yes.
you could get like 5, 6. You do like 5 and 6 for your first 2 rolls, and then you get a 3 for your third roll.
Okay. So, but this is also like flipping a coin and saying how many flips do you think it's going to take until you get a head on average?
Yeah.
Okay. Half the time you get it on the first one.
And then that means a half you don't get it.
Yeah. And so what's the probability that you get it on the second one?
It would be a 4th.
4. And on the third?
An
8th.
Okay.
16th.
All right. So there you go. All right. So this should take 2 on average,
So,
or 6/3.
there's 1.
Okay.
Now, we roll again. Oh. 3.
All right.
3.
And what should this take now?
Well, this should take 6 halves.
6 halves. All right. We don't need to do the rolls anymore. So just put it in, make it a 3. And what about the last one, which maybe is the easiest one to get the intuition on?
Well, it should be 6 over 1.
Why?
Well, you have 1 open slot. If you roll it 6 times randomly on average, you expect to get every number.
Okay. So if I'm going to try to choose a specific number, it should take me how many rolls to get that?
It should take you 6.
6. So 6 over 1. Okay, so my expected, and I'm going to change the 1 here on the first one to be 6 over 6. So my expected number of times is 6 times 1/6 plus 1/5 plus a 4th plus
Third
third
of a half.
plus 1. 6 over 1. Interesting, huh?
Yeah.
And we could actually compute what that is on a calculator. Let me just bring up my calculator here. Okay, so 1/6 is as a decimal. Do you know what that is?
That is,
I think it's 0.16 repeating.
1/6666666 plus. Do you know what 1/5 is a decimal?
it is 0.2.
0.2
1/4 is 0.25.
plus. What about 1/3?
1/3 is 0.33333. It's 0.5. And then diet plus 1. So it's about 14 point.
We'll call it 14.7.
Yeah.
So right around 15, like I thought.
Yeah, that was a good guess. Now, you ready for the punchline?
Okay.
Right.